Yes, is the simple answer to that question. I ran a poll in my community tab and 2/3 of you agreed with that conclusion. The metaclasses are indeed the hardest thing in Python. So I thought I'd provide a detailed overview of what they are and how they work. Now naturally, like a lot of things in Python, the more difficult the concept is, the more important it is to the core of Python, and metaclasses effectively make up everything in Python. And this is because everything in Python is an object, objects are all made out of classes, and classes are all built using metaclasses. So as far as the Python API is concerned, metaclasses are as low level as you can get. With that being said, the use cases for them in general Python programming are fairly limited, which is good and bad in a sense because you don't necessarily have to deal with the complexity all that often, but trying to explain them in the concept of something that metaclasses are best at is quite difficult to do. In this video, we will talk about the basics of metaclasses, how to create custom metaclasses, a use case where you shouldn't use metaclasses, which would be very important, and a use case where you should. But before we go into all that, I want to talk to you about a service called AltaHost. AltaHost is a fast and secure hosting platform with all the features you'd expect for less. Whether you want the affordability and simplicity of a shared hosting solution, the power and control of a virtual dedicated server, or just want to have a game session with your friends, AltaHost has something for you. They don't just excel at hosting though. The domain register lets you pick the perfect name for your website with any popular domain extension. And if it's SSL certificates you're looking for, they've got you covered there as well. Speaking of security, AltaHost has features that would please even the most security conscious. With DDoS protections and daily backups included as standard across all hosting packages, you can host your websites and services worry-free. They provide an easy-to-use dashboard to manage all your services, and in the event you do run into some trouble, their 24/7 service team is available to help you every step of the way. To host your website or service on AltaHost today and take advantage of all those benefits, make sure to head over to altahost.com or click the link in the description below. But with all that out of the way, let's tackle the hardest thing in Python. Before we dive right into creating custom metaclasses and all that, I do want to talk about the basis of metaclasses, and that is the type built in. So you may have seen, I'm in the wrong window. You may have seen a number of times where you use, say, type to get the type of a value. So you could do type 5, or you can print type hello. And if we were to run this, we would get class int and class string. This is a very common use for type. What you may not have known is that type is actually responsible for creating every class in Python. And you can actually create classes dynamically using the type built in. So if I were to, and I'm going to use my favorite example, the profile. If we were to create a profile and we would say type, we would then give it a name, profile. We then give it a series of bases. You can either leave this empty for now. I'm going to use object because that seems a bit more proper. And then you can pass a series of attributes. So I'm going to say my name is Ethan. My age is 25. My job is a software engineer. And you can actually pass in methods as well here. So if you wanted to do the string representation, you could do that and do lambda self.name is self.age years old. And now if I did p equals profile and then I printed p, we get the string representation back. And if I were to print type p to show it off, and if I were to print, I've got some other stuff in my notes. If I just copy paste that as well to print some of these attributes, then we see that it is indeed of type profile, and all these attributes are successfully set to the class. And we haven't used the class built in once here. Now, of course, if you did want your class to inherit from another class, you could do that. So if we created a class using the boring class method way base profile, and then we just set x equals 5 for a quick little explainer, we could set this to base profile here. And if we printed p dot x, we see that x is indeed 5 because we have taken this base class, we've created a profile class based on that class, we've inherited from it, and now we've inherited all its attributes as well. So what's important to note here is that the class keyword is just syntactic sugar for this type, and that is because type is a metaclass. In fact, it's the big boss of all metaclasses. All metaclasses must inherit from type in order to work, because type contains all of this information, all the methods necessary, all the attributes necessary to be able to create classes. And this profile class here is pretty much exactly the same as this profile class here. So I've just recreated it using the class syntax. We have the same initializer, we have the same string method, we're inherited from the same things. If I were to create a class using this, and we print that, not that, that, we get the same string back. Now, of course, using type to dynamically create classes is not necessarily the most useful thing in the world, but it is quite important to know, because when you actually create a custom meta class, you can refer back to that. So we're going to do that now. So if we get, we want to do that above here. We do class profile meta, and we are going to inherit from type. And we're going to do def init, and this is going to be class, not self. We have a name, which is a string, bases, which is a tuple of type of any length, and then attributes or namespace or DCT or whatever you want to call it, which is a dict of string to any. That's going to return none. And then I'm just going to copy paste this in here. And it's just going to be a bit of a logging thing. So this, if I just do from typing import any there, not and, there we go. This is called whenever you create a new class. So we can see that this print statement says creating class of name, and then we're just doing some debugging to show the name, the bases, and the attributes. And you'll notice that this signature is very similar to this signature down here. So you have the name, the bases, and then all the attributes. It's the same thing. And that's because when we call super.init, we're actually just calling this directly. And to actually set profile meta as our meta class, we come in here and we do meta class equals profile meta. And by default, the meta class would be type. But in this case, we're providing a custom meta class. And now if we were to run this, we haven't actually set anything to run. Oh, we have set anything. There's something to run down here. If I get rid of this for a second, then we get creating class of name profile, and then we have information. So name equals profile, bases is the base profile, so that's what we did before. The attributes does look a bit different because the class keyword does a little bit of extra magic in the background. So it adds the module, adds the qualified name, and it has your functions here rather than attributes themselves. But it does very much the same thing as just calling type directly. I just want to add a quick note about why they're different, because I noticed that I misspoke here slightly. So the reason that they're different is because in the original example, in the type built-in example, I set the name, age, and job attributes as class attributes. And in this example, I've set them as instance attributes by accident. So that's why they're different. If I were to set them as class attributes here, they would appear the same in the dictionary. So it's just worth keeping in mind that no matter what you assign to a meta class, it will always appear on the class as a class attribute, not an instance attribute. Now, if you wanted to, you could override how creating instances of that class works as well. And you can do that by doing def dunder call. And this also takes a class. So this is taking the class that we want to initialize. And we just take args any, quargs any, and then we return any for now. And then I'm just going to copy paste what's in here. So now we are creating an instance of class.dunderName. And then we just print the args and the quargs, and then we get super cool. We can then uncomment this and see what it prints out. So now down here, we are passing Ethan as the name, 25 is the age, software engineer is the job. And we can see that here in the args. If we were to pass any keyword arguments, so if I were to do job equals instead, that would come up here. So this is just the arguments provided to the class constructor. And then, of course, we just get a string representation down here. You can do dunder new as well to control how the meta class itself should be created. I don't really want to go into that because this is not a complete uber complex overview of everything. But I will say that if you were to do that, the first argument would be MCS for meta class. Or actually, I've seen it before where you can do meta class like that. I think both are pretty much accepted. But yeah, we're not going to touch that for now. Before we move on though, I just want to talk about typing considerations, because meta classes can be a bit weird with that. So if we go down here, we can see that P actually registers as type any. And then if we print P here, we just get a variable type any. And that's because the call is returning any. So whatever is returned out of the call, the type checker will actually use down here. It is a very easy solution to fix this. We just need to turn this into a generic meta class. So I've done a video on generics if you want to see them, and that video also covered what type vars are. So I'll leave that in the cards. Type var T, like that. And then we just need to change this to T here. And then we need to get this to inherit from T. And this is using the old syntax. You can use the new syntax if you want, perfectly fine. But now we've created a generic meta class, and this is of type T, and this mercifully is enough for it to work. For some reason, there's just a bit of magic that goes on at some point, and we can see that P is now profile. I am wary of overcomplicating this video, but I did want to cover that type safety because I knew that a lot of people would be interested in that. Now, one of the keys to fully understanding meta classes is knowing when and when not to use them, because there are a lot of places you could use meta classes, but the vast majority of which are better served by some other simpler way of doing things. And I did want to show an instance of that off because that is a very important part. And one way you can do that is by using the singleton pattern. So for those that don't know what a singleton pattern is, very simply, it is a class that only allows a single instance of itself to exist at any one time. You could either error it out if you try and create another instance, or you could do what we're going to do here and just return the original instance when you create the class. So to do that using a meta class, you would do class singleton meta, and then you would pass in generic T like that if you wanted type safety, and then you would give it a type. Don't forget the type. And then we can have an instance of T or none equals none. And then we can use the dunder call to override the instance creation logic, and that needs to be a class, and that signature looks fine. And then if a class instance doesn't exist, then we just want to create a class instance using super.dunderCall. If it does already exist, then we think, okay, we can just return that back out. And before we turn this into a meta class, let's see what it does if we don't have that meta class logic in place. We can see that DBM1 and DBM2 are false because they are different database managers. And in this case, that's actually not ideal because you'd be creating two separate databases in memory, which is a bit confusing. There's extra overheads. I just wanted to use the database manager as an example here. If we then turn this into, or if we then applied the singleton meta class to the class, we now see that DBM1 is DBM2 because we create the first instance as DBM1, then we would create the second instance. We see that the stored instance is not none, and then we just return that same instance back out. So that is how you would do that in meta classes. However, it's not the simplest way you could do it, because as you can see here, you can do it just as easily with a base class, and it's actually a little bit easier to understand because you're not adding that extra complexity of a meta class. You're also not having to do these weird type hacks to make everything type safe. It just knows, it knows that DBM1 is a database manager. It knows that DBM2 is a database manager, and you can just use the dunder new, which happens at the same level as this dunder call. I think, if someone knows for sure, do let me know. I think dunder new is actually called first. No, it'd be called second, wouldn't it? Because this super.call would then call dunder new. So this happens a little bit later down the line, but it does the same thing in the end. At this point, you might be thinking, well, if a lot of meta class use cases are better served by a base class or maybe by a class decorator, depending on what you wanted to do with it, what can you actually do with a meta class that is useful in the real world, that is objectively best as a meta class? And I can give you one answer to that, and that is class properties. And I will explain what I mean. So if we do class properties.py, and then we do import random, there's a lot of setup to this. So we'll get to it. Fruits, can't even spell, that would help. Apple, sure, we'll have all them, why not? And then if we were to have some sort of configuration class, I've talked about class-based configuration classes in a different video. We could create a class property by using class method and then the property. And then we could say fruit here. This then takes a class, returns a string. And then we can put in some logging, which will become apparent why we're doing this in a bit. Just to better show off the problems with this. And then we can turn random dot choice fruits. And then if we do if name equals dunder main, and then do print config.fruit. So what this is doing here, we just have a series of fruits. We then have a configuration class. We have a class property that we can call like this, and this will choose a fruit for us. And on the surface, it works just fine. It chooses the fruit, it waits a second to simulate actual work, and then it chooses a fruit, in this case, cherry. However, it is deprecated. So this doesn't say it, but this will. Class properties are deprecated in 3.11 and will not be supported in Python 3.13. We're using 3.12, which is why this still works. But why is it deprecated? Well, it's because it's buggy as hell. So if we did help config, if we ever wanted to find help, and this is how it was found, it happens in a few other situations as well. We would choose the fruit, we'd then choose the fruit again, we then choose the fruit again, we then choose the fruit again, and then we'd get the help. Why exactly this happens, I don't fully know. It's something to do with the way the descriptors are set up, something to do with the way that, well, help has to like scan and access the object to find all the documentation for it. And I guess in doing that, it just triggers all this stuff, which is not ideal, especially if you want to do other stuff that triggers this. One way you can fix this, and we're going to uncomment this, is by converting this into a meta class, or specifically moving this functionality into a meta class and then having a meta class here. So if we did class config meta, and that inherits from type, and then we take this logic out of here and we put it in here, and then we can actually just pass this out completely. And then meta class, just pretend there's something else in there that you need. Meta class equals config meta. We now see that config.fruit is still accessible. And now we see choosing fruit, which it does. And then it prints the fruit. But you'll notice that it didn't choose the fruit 4 times before going to help. It just went straight in. And this is the difference between meta classes and classes. And it's a very important thing to note that anything you create here within the meta class is created as a class attribute, a class method, or in this case, a class property of the class that you're attributing the meta class to. And I don't fully know why this bug doesn't happen when you use it in meta classes. I have a feeling it's something to do with the order of operations. So this property gets assigned to the meta class, and then the config effectively just inherits it in a way, rather than actually creating it at the time. So it's already created ahead of time, something like that. That's my theory. I don't fully know the reason why. But that is one instance where meta classes genuinely work very well, and something I've had to do in the real world. I had to do something very similar to this when I built a type safe, lazily evaluated configuration system using descriptors and all sorts. I actually had to use meta classes in this way because there were attributes that I needed to calculate lazily using other attributes that are attached to the class further down the chain, so they couldn't be attached directly. They needed to be a property because I didn't want it to be called as a method. But then I ran into this bug with the help. It was a big slog. But I found out in the end that these class properties can work using meta classes. So this is actually in use in the real world. And from the research I did when I was investigating that bug, It seems there is quite an audience for a feature like this. But that is a brief run through of metaclasses. If you didn't understand everything in this video, that is perfectly okay. Metaclasses, in my mind, are pretty much the hardest things in Python. As I said at the start, there was a poll that kind of confirmed that really. So it's just a case of finding a use for it and practicing with them. If you do have any questions, do leave them in the comments. If you have used metaclasses before in the real world, then do let me know how. I really want to know some other really cool use cases for these to strengthen the case, because I think that creating custom metaclasses is not necessarily the worst thing in the world. I know a lot of people are completely against it, but I do genuinely believe there are use cases, and I want to learn some more from you. If you want to find out about other ways that Python is awesome, then I have a whole series dedicated to it that you'll find in the cards. But I'll see you in the next one for whatever we do next.